You posted them?
It was shared. It was shared with your email ID, and an email was sent to you last week. Okay, I think Gavin is missing too.
Yeah, Gavin is
Let
missing.
me see.
And this is being recorded.
Did you share it with my dad or with me?
Go ahead and type your email ID so I can double check.
Reese, you want me to help you out set up your IDE so you can, because they're just going to do a review and stuff. Do you want me to quickly help you out with that?
With what exactly?
You said you had problems with your IDE or something.
Oh, no. Just it's just my command line wasn't working, so I'm gonna use Notepad Plus, and I'm just gonna type in there, and then I'm gonna copy and paste that into my IDE, and then run it there, so I don't have any of the features helping me.
Oh, I see. Oh, okay. I thought you were just having problems with your IDE.
Yeah,
No, my IDE is fine.
I'm gonna do that as well, I think.
Sounds good.
All right, should we start? All golden, right?
What time is it now? There you go. Gavin's in. Okay, I think we can get started.
Gavin, I think we have a quorum now. So let's start.
Yeah.
This is where we left last session. So quick review.
Fernando and PK will be assisting you this evening.
Awesome.
Thank you.
So you guys observe me looking sideways. I'm actually looking at a different monitor where I'm running the slides. So I am paying attention only on the second screen. Also, if there's any question, feel free to unmute yourself and ask it out, or type it in the chat window, and Kumar, Fernando, or PK can go ahead and read it out. Because I don't have access to that while the slides run. Being said so, last session we learned about operators, essentially the same that we use in math, which is addition, subtraction, multiplication, division, and a special one which is not oftenly used but very helpful in programming, the modulo operator. And we saw these questions which were very centric around modulo. I hope you all had a chance to practice more of it, and let me know if there's any question around it. We can address that before we proceed any further. Just a quick recap. Modulo is something that returns a remainder. So if you do x modulo y, the result will be whatever is the remainder of dividing x by y. Versus if you do x forward slash y, it will just give you the quotient, not the remainder. So when we have that context set, let's go ahead with today's session. We'll continue from where we left last time, and today we'll start with the unary operators, which so the difference between the previous one and this is unary is like it requires only one operand. It doesn't require two. As an example, in the previous example we saw, we required two operands, x and y, or two numbers with which we can add or subtract them, or divide, or whatever operation we can do. So we needed more than one operators. But these ones that we're going to look at are special operators provided by Java, which requires only one operand. So as an example, we'll consider x as a variable and its value set to 4. And the first unary operator we'll look at is unary plus. It indicates a positive value. So you can write integer x equal to 4, or you can write integer x equal to plus 4. Both mean one and the same, but plus is optional here. It is assumed that if there's no negative, it's going to be a positive number. So we don't have to write explicitly plus 4, but you can go ahead and do that and it'll still be fine. So this just says a number is positive. Similarly, there's a minus, which means it negates an expression. So if you want to represent minus 100, a negative number, then you would do int x equal to minus 100. Right? That's how you tell Java that the number is negative. The one after that is very interesting. It's called the increment operator. Increments a value by +1. It's a very old unary operator, very commonly used in the industry. If you guys have heard of programming language C, the language C++ actually named itself C++ because of this operator right here we are looking at. And it is also supported in Java. So what it does is it increments the value of that one variable by, like whatever variable it is, by 1. Which means if you do x++, it will make it 5. And so instead of writing x is equal to x plus 1, we just do x++. It's a very shortcut way of doing it. Now there are two variations of it. Either you can do x++ or you can do ++ x. What is the difference here? Definitely first is postfix and the other is prefix. But what postfix does is when you do x++, it will replace that expression with whatever is the current value of x. Evaluate the expression and then increment the value of x to x plus 1. Whereas the later one, which is a prefix, will first increment the value of x and then use it. So there's a very subtle difference. We'll look at it in more detail as we go further. But x++ is what is covered in AP syllabus. So we don't have to worry about ++x. It's good to know that something of such kind exists, and you will use this in a scenario where you want to first increment the value of variable and then use it, versus the postfix, which uses a value and then increments it. But we'll stick to x++ as part of syllabus. The next is decrement operator. Similar to ++, it reduces the value of a variable by 1. So essentially, if you do x minus minus, it will give you 3, and it has a similar prefix version as an increment operator, which is a minus minus x will give you 3 as well. And the same difference applies here. X minus minus will first use value of x and then increment it, whereas minus minus x will first decrement it and then use it. A prefix version is out of syllabus, so we'll be using x minus minus in our coursework, but it's good to know. And finally is exclamation mark. Right? Surprising, isn't it? So the surprising part is it doesn't work with all types of variables that Java supports. It is primarily for Boolean types. So if you do x equal to exclamation 4, it won't compile, because in our case x is an integer and it just won't accept it. So the way to use it is, if you do a exclamation true, it would mean false, and vice versa. So this is very helpful when we evaluate things, like when we check if certain conditions are true or not true. So when you want to check something is not true, then you would put an exclamation right before it, and Java would understand that you want to check if it is not true. Any questions on this?
Wait 1 second. What was the difference between the plus and the minus again? I mean, the in front of it and behind it.
So the one in front, which is postfix, it will first use the value of x and then increment the value of x. So we'll look at an example that will clarify this. As an example, what I would say is if someone writes a program which says x plus plus, let's say x value is 4, as in the example here, and then you write an expression 1 plus x plus plus. So the result will be 5, and the value of x will be 5. Well, let's look at a different example. So on a piece of paper, if you all write, as I said, if you write, let's say, uh, um, 5 plus x plus plus, the result will be the result will be 5 plus 4 is 9, and the value of x will be 5 because x plus plus incremented the value. But when it was evaluating the expression 5 plus x plus plus, it used the current value of x. So after using it, it incremented the value. Whereas the prefix, what it would do is it would first increment the value of x and then use it. So instead of x plus plus, if you had an expression called such as x plus plus x, what it would do is it would first increment value of x, which makes it 5, and then it'll add 5 to it, the answer will be 10. So you'll see that the result is 1 less when you use postfix versus when you use prefix. We'll look at an example real quick that will clarify our understanding on this. Right? It's in the next slide. Any more question? All right. Let's move to the next slide, and we'll understand increment and decrement operators in a little more detail in this one example. So everyone, inside your main, don't change the class name. Just inside the main function that we had written, remove everything. And if you can quickly type this program, that'll be awesome. It'll help us understand the unary operators.
Wait, do we type in the CMD?
Come again?
Do we type it in the CMD?
No, if you're using IDE, type it in the IDE or like type it in a file, like a Java file. Remember we had a hello world class, and then in that hello world.java file, inside the main function, just type this whole thing out and run the program. If it is not clear, do you want to share your screen while everyone else is writing? So
Sure.
for everyone to look at it and
So I go into this one.
Okay, so yeah, IntelliJ is fine. Open that. It'll take time. Okay, so that's not the right one. Okay, do one thing. Close the hello world.yml in the background and go to File. Open IntelliJ. Yeah. Okay, there it is. You see that hello world right there? We have close this tip of the day.
Mm.
And then in the background, you'll see this class hello world, and then you have this main function, right?
Wait, which is class?
Yeah, right there. This one.
Oh, okay. Yeah.
So you have this.
So you stopped sharing your screen, so I'm not sure what to write right now. I don't know if you did that on purpose, but
Give me
sorry.
just 1 second. I realized that. Looks like I can only one can present.
Yeah.
I believe.
Okay, I can stop
But
presenting.
Harris, you got a point, right? So within the curly brackets of the main function, You have to type
This.
it, right? Yeah.
Okay.
Right. Oh,
Okay.
let me resume.
I'll stop.
Okay, everyone can see this, right? We are
Yes.
back into this. So you all get 3 minutes to type this out and run it. Your time starts now. And if you get done sooner than that, then look at the output and try to guess what's going on with it. I'm putting a timer so that we don't spend more than time required. As you get done, you can write in the chat window so that if we all get done before the time is up, can resume. A lot of exciting stuff coming up next.
I have a question.
Yes.
So I just like ran the code, and for some reason, when I do the line that's plus k, it gives 21. But then when I do minus k, it gives 20. So why would it change when I do the plus k, but not change when I do the minus k?
Okay. We'll look at it.
Okay.
We'll look at it in a moment.
Yeah, I got the same thing too.
All right. We have 20 seconds left. Once time's up. Anyone requires more time? Should we continue? I'll recommend that everyone runs this because it's a very interesting output here. More time? I think I do not hear anything, so let's assume everyone's program is running. So I hope you all got this output. Anyone with a different output? Guess not. So Edward, question to you. So why did we get 234 as an output here? So this is an output for line number 11. So line number 10 prints 234. Line number 11 also prints 234. Any guesses?
Isn't it because we we basically got the value of it before we added it. So basically it's printing the number before we added 1 to it.
Correct. So that's the postfix operator. So what it does is it first evaluates the expression. So it will first print it with whatever value of I is, and once that operation is done, then it will increment the value of I. So at line 10, we're just printing whatever value of I, which is 234. So that's correct. That's what is expected. But in the next line, what it does is it first like prints. So it replaces the I++ with value of I and then increments it to the next number. So in line 11, it still prints 234, but at that point, the value of I is 235 in the memory. So that's right answer actually.
Wait, so sorry, so for line 12, if you put in line 13 and then you just put and then you just printed I, it would be 234 again, right?
No, it'll be 235. Quickly, you can try
Oh
that.
yeah. Wait, isn't it? No, because isn't it 235 minus 1 then? Isn't that the next one?
Well, yeah, actually, so you are right. So if after line 11, if we had another line which would just print out value of I, that result would have been 235,
Yeah.
right? So that answers your question. Now the next question is, would you like to take a guess? Why do we get 235 at line 12, even though we have a I minus minus?
Oh, it's for the same reason, because it just prints. Because 235 is the value that it was given before, right? So if the next value would be 234, it would do it for
It's
the
like
next one.
postfix, right?
Yeah.
Correct, yeah. So you're right. In the next line, if we had a print line I, then the value of that would have been 234 again, because as you rightly said, it's a what it does is it replaces value of I with 235, whatever the current value is, and then decrements it by 1. So that's why we get 235 at line 12, but it's not very intuitive unless we completely understand the postfix operator. The next one, let me pick a name. Nate, do you want to take a guess? Why do we have 21 in the result here on line number 13?
Because you did plus k, so it's like you're incrementing the k by 1, right?
Yeah. So right here, you're right. It is a prefix, and we see the at line 11, we did I++, and it still printed the same value of I, which is 234. But in line 13, we did a plus plus k. So instead of printing 20, which is the value of k, it printed 21. So it shows that what it did is it first incremented k and then printed it. So it evaluated the expression after incrementing. Whereas line 11, it evaluated the expression before incrementing. Does it need clarity?
Because you put like the plus in front of the k.
Yeah. So it will first increment k and then evaluate the expression print line.
Oh, okay.
Yeah, but at line 11, first it executed print line with I and then incremented the value of I.
So it didn't update it.
Yeah. So that's why you see 234 printed twice instead of 234 printing just once. All right. Next, let me pick a name. Hallie. Do you want to take a guess? Why do we have 20 here at line 14?
You have 20 because you did minus k, and that's incrementing. Incrementing it. Actually, I don't know, because it's would be technically 19, but it's not.
So that is an interesting view at it. So your hunch is right. The reason why it is not 19 is because at line 7, k value is 20. But at line 13, we did a k plus plus k. So the value of k became 21. And at line 14, we did a minus 1 is k. So it first decrements k. So from 21, it will make it 20 and then print it out.
Oh yeah, that makes sense. Okay.
Right? So it's sorry, go
Wait.
ahead.
So I have a question.
Yes.
Wait, so when you print like plus plus k, that actually changes the value of k?
So when you do print plus plus k, it will first change the value of k,
Uh-huh.
and then run the print command, and then it will pass it as a parameter to print.
Okay.
Whereas
Yeah.
if you do k plus plus instead, like I plus plus, then it will first send the value of I to print, and then it will increment the value of I.
Yeah, that makes sense. At first I thought that like when you print it, it doesn't change the value. It just prints like k plus plus, but it doesn't actually change k.
No, it changes k. So that's the difference
Okay.
between the prefix and the postfix. So
Yeah, that's
postfix
Uh-huh.
postfix will change the value after evaluating the expression. So in case of line 11, the expression is print line. So it will first print the value and then change the value of I.
Okay.
Yeah. Right. We'll get a little more clarity as we go further in the slides. But it is very interesting. If you have not come across the increment and decrement operators, it's a good thing to learn about or read about. Very interesting. So moving on. So we are in the third set of operators. So far we have done unary operators. The previous session was about arithmetic operators, and the final set of operators we are going to look at is assignment operator. Now, if you look at the name itself, assignment operator, it means it is something that assigns value or a result, right? So as an example, int x equal to 4, in this case, we are assigning 4 to x. So the equal to sign is an assignment operator, right? So that's the simplest one. It's a simple assignment operator. So if you do x equal to 5, it will make x 5, right? The next variation to that is add and assign. So programmers have this habit of creating shortcuts. It's a very simple expression they have come up here with. So instead of writing x equal to x plus 6 as an example, what they will do is they write x plus equal to 6. And it's a shortcut. You don't have to write x twice. Zain, do you want to guess what is the result of x plus equal to x here?
Wait, so is x equal to 5 originally?
X equal to 4. So for every for every case, let's
Okay.
say x equal to 4.
Well, then it would just be 8.
That's right. Yeah. So what he did is it's like equivalent to writing x equal to x plus 4, which is 4 plus 4 makes it. Sorry, x equal to x plus x, which is 4 plus 4 makes it 8. All right. So the next one is subtract and assign. Similar to add and assign, there's a shortcut for subtract and assign. X minus equal to 6 would mean x is equal to x minus 6, which makes it 2. So, Edward, do you want to guess the result of x minus equal to x? So we can expand the expression. So x minus equal to x would be similar to having x is equal to x minus x.
So 0.
0, yeah, that's right. Next is multiply and assign. Similar to the above two, x asterisk equal to 4 is x equal to x into 4, right? That's 16. So it is multiplying. It's a shortcut. Sam, do you want to take a guess at what is x asterisk equal to x evaluate to?
16.
That's right. So it's a quick way to find a square, isn't it? So no guesses. Next is divide and assign, right? And it just follows a pattern. So same x forward slash equal to 2 as an example would mean x is equal to x divided by 2. And in this case, if x is 4, divided by 2 is 2. So Rish, do you want to guess what would be x forward slash equal to x be?
I'm sorry. What is x equal?
4?
Oh, 2.
No, the next one, which is x forward slash equal to x. So if we expand that expression,
I'm sorry. What am I trying to find? What am I trying to find?
the result of x forward slash equal to x, the last line in the slide, where there's a question mark in the dividing the sign.
I'm not sure. Sorry.
So if you look at the example right above it, x forward slash equal to 2 means x is equal to x divided by 2. So x forward slash x forward slash equal to x would mean x is equal to x divided by x. So in this case, the answer will be 1. But this is a handy shortcut. It's not required to use it all the time, but it's good to know. A lot of programmers use it, so it's good to be familiar with it. And finally, the last is modulo. Again, it comes back all the time. So x modulo 3 is equal to 1, because if you divide 4 by 3, the remainder is 1. So Parashar, do you want to guess what is the result of x modulo x here?
Sorry, could you say it again? For the modulo one, right?
Parashar?
Can you not hear me?
I can hear you, yeah. So I was just trying to take a stab at what would the expression at the last end of the slide would evaluate to.
I think maybe it's 4.
Not really. So if you expand x modulo equal to x, it would be equivalent of writing x is equal to x modulo x. So you're dividing a number by itself, so it's going to have a remainder 0. Right? Can be 4 divided by 4, so the remainder will be 0. But you guys got the point here, which is these are all assignment operators, and they are kind of shortcuts to do arithmetic operations on numbers. So we can write a program, but let's not do that. I think it's very intuitively easy to figure out what the result is going to be. So let's just look at the result and see if it makes sense. So at line 5, I is 245. Line 6 is I plus equal to 5, which is equivalent of writing I is equal to I plus 5. And if you print it, it would be 250, right? The line number 9, it's I minus equal to 50, which is equivalent of writing I is equal to I minus 50. So 250 minus 50 becomes 200. There you go, it prints 200. Line 12 is I asterisks equal to 50 or 5, which means I is equal to I into 5. Now the value of I is 200, so 5 times 200 is 1000. Our output is right. Line 15 is I forward slash equal to 23, which is equal to equivalent of saying I is equal to I divided by 23. So 1000 divided by 23 is 43 point some number after that in the fraction. But as I is an integer, it'll drop the fractional part, and what's left is essentially quotient, 43. Now, line number 18 is I modulo equal to 40, which is equivalent of saying I is equal to I modulo 40, which is equivalent of saying give me the remainder of I divided by 40. So I is 43 at this point. You divide it by 40, so the remainder is going to be 3. And that's what we get in the last print here. Any confusion? Any questions? No questions? I mean, so you all are understanding it all well. So let's move to the next slide. Operator precedence. Don't get worrying about what are these precedences and increment and decrement and prefix and postfix. They're very easy. It's just that maybe these are new terms. That's why it looks that way. But it's very intuitively easy if you practice it at home. So what does precedence mean? It means the order in which things get executed, right? So from your math lessons, you all remember BODMAS? Uh, can anyone? It's an open question to the stage. Can
Why
anyone
is there,
guess
oh, isn't it like an E?
come again?
Isn't it supposed to be bed mass?
I
Oh,
know it's PEMDAS.
Yeah, it's PEMDAS. Yeah, that's
Like
how we learned it.
PEMDAS.
Yeah, I learned it as PEMDAS.
Well, I learned it as GEMDAS now, but yeah, I used to.
okay, very interesting. So let's hear what all of those mean. So let's start with BEDMAS. That's very interesting. What does that acronym mean?
Brackets, exponents, division, multiplication, addition, subtraction.
Okay. And how about the other one? I think Edward, you had. I mean, Rish, did you have a variation of it?
Oh no, I just remembered.
It's parentheses, then exponents, then multiplication, then division, then adding, and then subtracting.
Okay. Interesting. Any other variation of it?
I don't get what the O stands for.
Well, I learned something new today. But essentially, we all were talking about the same thing here. So in this case, BODMAS means bracket off. So you first take care of the parentheses, and then division, multiplication, addition, subtraction.
Wait, so that means
So-
that there's nothing for exponents then?
Yeah, BEDMAS is actually better. It has something for exponents there, right? But this was for a very basic arithmetic acronym, so it didn't have exponents. But the point here is that when we do math, there's a certain order of things in which we solve equations. Right? We first solve for brackets, and then division, multiplication, addition, subtraction. A few things can be interchanged, like division and multiplication can be interchanged. Similarly, addition and subtraction can be interchanged. But we try to follow a certain rule, right? Similarly, in programming, there's a certain order in which Java executes everything that you write. Let it be print statement, let it be assignment, addition, subtraction, could be anything. There's an order in which it executes it all. So to understand that order, let's start from the bottom. Assignment operator, because we all understand what it means. If x is equal to 3 plus 2, the answer is 5. So value of x is equal to whatever is to the right of the equal to sign, isn't it? So the assignment operators precedence is right to left, which means if you have an equal to sign in your program, Java will first run everything that is to the right of equal to, and after that it will take the value of whatever that output is, and it'll assign it to the left of it. Make sense? So when we do x is equal to 3 plus 2, it will first evaluate 3 and 2, like it will evaluate 3 plus 2, and then assign the value to x, which is on the left. So it will assignment operator works from right to left. It will first solve right and then solve left. The next is additive. So its order of precedence is left to right, which means it will first solve everything which is to the left of it, and then it will solve everything to the right of it, and then it will add them together. So if we have 3 plus 2, then it would first pick 3 and then add 2 to it later on. Right. Similarly, if it is 3 minus 2, then it will first take 3, then it will take 2, and then do a subtraction of them. Right. The next is multiplicative, which is all multiplication, division, and modulo. It's a common term for that. Even their precedence is left to right. which means first Java will evaluate everything which is to the left of this expression, and then everything to the right, and then it will multiply together or divide or whatever it is. So if it is 3 multiply 2, it will first pick up 3, and then it will then pick up 2, and then it will multiply them together, right? So if there was something in the bracket before multiplication, then it will solve that first. If there's something within brackets or parentheses after multiplication, then it will solve that next, and whatever is the result of these two will be multiplied together, right? Now, unary prefix and postfix, you don't have to worry about it a lot, but it's good to know that they go from right to left, which means whatever is to the right of this expression will be evaluated first, and then this particular expression will be evaluated. So let's say if x is 5, then and then if we do x plus 5, let's say it is 3x plus 5, which means x plus plus, and then add 5 to it. So first it will take 5, then take the value of x, add them together, and then increment x, right? It's very subtle. And then parentheses, we all know, left to right is associativity of it. And the order in which Java runs these is it will first solve parentheses, then it will do unary operators, then it will do any multiplication or division, then subtraction and addition, and then whatever the result is will be assigned, right? Any questions on this? Anything which is not aligning with what we have learned in math? So if there's no question, everyone, between your main function, replace that code with this new code there, just 3 lines of it. It shouldn't take a lot of time. Let's have 30 seconds on the clock. The result of this is going to be very interesting. So see if you can run it. The time starts now. All right, your time's up here. So, did you guys get a chance to run it? Need more time? What is the result? Can anyone volunteer?
It says 30, yeah.
30? Anyone with different result? So, any guesses on?
Is it because? So first, is it because first it says x plus plus, so then that's still 5. It doesn't change there, and then the next one after that is x plus 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 plus, but that one already is known as 6, so then it's 5 times 6 equals 30.
That's actually right. So there are 2 x plus pluses. Which one do you think would have been replaced by 5, and which one would have been replaced by 6?
The first one would have been 5, and the second one would have been 6.
And why do you think that way?
Because the first one's because it's still 5, and then it's a postfix, so it hasn't really calculated that yet. But for the one after the multiplication sign, it becomes a 6, and then the plus plus is still postfix, so it doesn't really matter.
Yeah, well, that part is right. The reason why, let's go back to this real quick. So multiplicative is left to right associative, which means you rightly said that the first x plus plus would have been 5 and the next is 6. But the reason why it is this way is because there's a multiplication in the middle. So it will first evaluate what is to the left of it, which is the first x plus plus. And then the way it will do it, the way it'll do it is it'll replace that with 5 and an increment value of x to 6, and next it'll evaluate whatever to its right, which is another x plus plus. So it replace that with 6, and then now the value of x at this point is 7 actually, but the expression will be 5 into 6, which is 30. So that's what happened here, and your guess is very right. But the understanding here is whatever to the left is evaluated first, and then things to the right. So this is a very simple example. In a little more complex example, that difference would have been more obvious. All right, next program. Between your main function brackets, write this code and run it. See what the output is. We have 30 seconds. I hope you all are able to run the program. If not, then we can take a pause and address it. Because once the session is over, then it'll be amazing if you guys can practice more on similar lines and kind of get better at it. Did anyone get an output?
$12 and 3.
Okay. Why did you get that answer? What happened? What happened there?
Did it just combine the numbers because there were no parentheses?
Are you asking?
So it did that, but why did it do that? You're right.
Oh yeah, because it was a string. It thought it was a string, right?
Are you asking me?
Yeah, I mean it's a general discussion.
I accidentally typed in 2 equal signs instead of plus signs. It was just a typo.
Okay. But everyone got 12. Why did that happen? Someone said it thought it's a string.
Yeah, I think it's just because we didn't add parentheses.
Okay.
So is it 1, 2 instead of 12?
1, 2 instead of 12. Okay. So okay. But it's still not 3, right?
I think it thinks it's like a text string because, like, when you usually add other text strings, they sort of just combine together.
So I think we just put it right next to the string without brackets. So I think it just put the 2 numbers together.
So you guys are partially right, but there's a flaw in your explanation, all of your explanations so far. So if you're right about it is placed next to string, that's right. But so is the second expression. What's odd about the first expression is, well, 1 is placed next to string, but 2 is not placed next to a string. It is
Oh, I
placed
think I know.
Okay, go ahead.
Okay, so it's because the reason it works in the second one is because we have parentheses, so it's doing that first. And the first one, it's gonna do 1 plus 2, that whole string. Then it's gonna add 1 to the string before adding 1 to 2.
Yeah. So why did it do that? Why did Java do that?
Because of order of operations, it reads it from left to right.
You are right, yeah. So plus has an associativity, plus and minus has left to right, which means it is going to evaluate everything to its left and then everything to the right. So what it'll do is it'll look at 2, and then there's a plus sign. So it is going to evaluate everything to the left of the plus sign first. So it'll come to the left of plus sign. I hope you guys can see my mouse cursor move. So it'll look at this whole expression, which is a string plus 1, and it'll try to evaluate that first. So when it tries to evaluate that, it'll see the plus sign here again. So let me go to left and evaluate that left first. So it'll see, oh, this is a string, and it'll come back to right, and it'll see 1. So it'll assume that now the user is trying to add, it's trying to do a string concatenation. So it'll make it, this whole expression will become 1 plus 2 equal to 1. And then it'll go to the right of the plus sign here, and it'll see 2. And in the left, it is assuming that everything is a string. So it assumes that is a string concatenation and just adds 2 as a string to it. So you see 12.
Wait, so does the plus 1 get recognized as 10 in that case then?
No, it's not doing a math here. So let's look at it again. So when Java is looking at this whole expression, it will look at this plus sign here to the rightmost plus sign first, right? So when it looks at this plus sign here, is there a way I can draw on the slide? Let me see if I can draw. I think I can draw, right? Pen color. No, I think I cannot draw on here. But if you look at it, the first plus sign here on the right between 1 and 2, Java will first look at that, and it'll say, okay, it is a plus sign, so I'm going to, the associativity of plus is you evaluate left first and then evaluate right. So it'll go to the left side, and in the left it'll see this whole expression 1 plus 2 equal to plus 1, and it'll be like, okay, fine, first I'll have to evaluate this part here first. So it'll come to evaluate this, it'll see a plus again, and to the left is a string, and then to the right is a number. So it'll think that the user is trying to do a string concatenation. So it'll add 1 as a string to this whole expression. So at this point, until here, your expression is 1 plus 2 equal to 1. And then that's a string. So it'll go to the right of the plus sign, it'll see 2. On the left is a string, so it'll assume that you're trying to do a string concatenation, and it'll add 2 to it. I hope it brings some clarity. What it is doing is it is not treating 1 and 2 as numbers. It is treating 1 and 2 as string, and the only reason why it is treating it as string is because it starts evaluating things from left, and the leftmost is a string in this case. So it converts everything into string as it continues. So that's why we see 12, which is, it is just, it's not considering 1 as 10. It is not doing an arithmetic here. It's just doing a concatenation. Right? In the next statement, there's a bracket. So Java will again come here, but now there's the first expression, the first plus sign it'll see is here, and it will try to evaluate, as usual, left. It'll see 1 plus 2 is equal to is a string. Come to the right, and it'll see there's a bracket. So it has to evaluate that bracket as a whole, and then that results to 3. So it'll see there's a string on one side, and there's a number on the other side. It'll do a string concatenation, but this time, as there was a bracket, it did the arithmetic of it, and the result is 3. I could change that at least. Anyways, no. So, any question on this? I think there is some level of confusion, because it is a little confusing. Let me see if I can. I can't edit this at all. But give it a practice, and if there's more confusion, then maybe you know what I can write it down here, right? So that's very interesting. So all of you can have a look here. Dot out dot line. The first expression we have is 1 plus 2, right? Equal to, it's here, then 1 plus 3, right? And the second is where it is, that's the second one, and save it, then run that new one. So we get the exact same output, 12 and 3. So what happened? So what Java did is it came here. It decided to first evaluate this part, right? So it tried to do that, and when it tried to do that, it saw there's another plus. So it tried to evaluate this first, and then it tried to evaluate that. So this is a string, and this is a number. So it will do a concatenation, and then this will look like 1 plus 2 is equal to 1. This whole expression will be that, essentially. And then what it will do is it will add 2 to it. Okay? So this is equivalent of saying 1 is the equivalent of saying 1 plus 2 is equal to 1 plus 2. Okay? And this will become everything here is a string, that's a number, so it will do a concatenation, and this will print out 1 plus 2 equal to 1, 2. Sense? But if this was here, this would evaluate to 1 plus 2 is equal to, and then on the other side, there is 1 plus 2. So it will evaluate this to 1 plus 2 equal to, and then plus 3, that is equal to 1 plus. So you'll see print out as 1 plus 2 equal to 3. So it's kind of really subtle, but very interesting. Tests the knowledge of precedence of operation. All right, quick quiz, easy one. Evaluate the value of expression. So, Alice, what do you think the answer is? Alice? All right, maybe he's on mute, I guess. Gavin, do you want to guess what the answer is?
Oh, I don't know. You don't do it left to right, right? You do it like in terms of pandas.
So this is a little simpler than that. So this is you have to apply the bedmass rule, which is first evaluate 10 modulo 4.
Right.
So that is 2.
2.
Right, and then the standard subtraction and addition. So minus 2 plus 2 will make it 0. Then that leaves us with 6 plus 7.
So 13. So
13.
C.
Yeah.
Okay.
All right. So let's look at this. Parashar, do you want to take a stab at this? What is the output of the program?
Yeah, let me look at it. Wait.
In fact, you all can run this on your computer and see what the output is. It is very interesting output.
Is it -1?
It is, yeah. You're right. It's -1. But why is it -1?
I would just think because there's 3 negative signs and then there's 2 positive signs. So I don't know. I just thought maybe because you just take out the 2 positive and negative, and then you have A minus B. I don't know. I just made that up. I winged it.
That is very interesting. Maybe next time I'll change the initial value of A and B from 1, or no, I'll change it to something else. The result will not be -1. But in this case, it is -1. The reason is not because of that. The reason is because of this. What is happening here is Java is evaluating that whole expression. It puts brackets for you internally. So if you try to bracket things together, you will realize at the end this whole expression evaluates to A minus B. That's why it's -1. If A would have been, like, let's say if B would have been 5, then the result would have been like -4. But this is how Java internally works. It kind of tries to follow the precedence rule when you have complex expressions like such. All right. So the idea was to write this program, but in the interest of time, let's not write it. Let's think it through, right? Let's talk about it. Let's build the logic of how would we solve it. So this question goes to Edward. If you have 3,678 pounds of sugar equally divided among 67 people, how many pounds of sugar will each person get?
What, like precisely, or do I use modulo to?
Precisely.
What do you want me to put that on a calculator?
You can. I mean, the idea was to write a program, but it's fine. You got the gist of it. When you, as you rightly pointed out here, is when you need exact division.
I got 54.895522.
Yeah. So when you need exact number, then you do a division. But the idea behind this question was to write the use data type. So if you would have used an integer for storing the result, you would miss the fraction part and you would get wrong result. So the idea was to use a double in this case to get the result.
Okay.
Right?
Cool.
How would you program that again? It's
all right. Let's write one together. It's gonna be quick. So what we'll do is double, and then it says LB sugar, right? How many LBs is 3,678 pounds, and then as the number of people, we don't. It doesn't. The LB sugar doesn't have to be double, but let's not do it double. Let's keep it simple, and then we'll figure out people count. This has to be divided equally among 67 people. Right? So system.out.println. Let me introduce one more int share is equal to LV sugar divided by people count. Right? So each one gets that much of share. Each person gets that much be sugar, right? Then let's run it and see what happens. So each one gets 54 LB sugar, right? which is not right. There's no fractional part to it. We know that these two numbers are not exactly divisible. We did the math right. We got the result wrong. Is because we use the wrong data type here. You know, if we use the integer all around. So let's change. We know that the result is fractional. So let's change it to double. But the point here is using wrong data type can give us wrong result. So when you're writing your AP exams, you have to be careful about what data types you choose. So let's, we know the result is fractional. Let's make the share double. And any guesses what the result will be? What did your calculator say? 54 point how much?
54.89 something 55.
Okay, let's see if we get that result. Oh, we did not get that result, 54.0. So we use the right data type. We got the wrong result. Why did that happen? Any guesses?
It's because it's dividing an integer by an integer.
You're right. So what Java is doing is it is looking at these two, and it says, oh, this one is integer, the other is integer. So I'm going to assume the result is going to be integer. So it drops fractions, and then it assigns it to a double. A double assumes that there's going to be a fraction, but in this case, fraction has been dropped, so the fractional part becomes 0. So now instead of getting 54, we are getting 54.0. So that's not right. So what do? There are two ways to fix it. One is you typecast. So you say Java that consider like LB of sugar as a double. Don't treat it as integer. Let's see what happens. Now when we run this, we'll see that our output is, we do get an exact result, right? So what happened here? So when we did a typecasting, we told Java LB sugar is of type double. Now people count is an integer. So what Java does is automatically it converts integer to double. Remember, it was called type widening. It is very automatic the way Java does it because it's converting a low, a smaller type to a bigger type. So there's no loss of information. So it can do it without concerns. And then it treats both of them as double. Result is double, and that's what we get printed out. Could we do it another way? Yeah, we can do it another way. Is we could have started off as double here, okay, and then the same result. There it is. So the choice of the whole purpose of this exercise was to make sure that our choice of data type is right. Because in the exam, if you get something similar, wrong data type result will have wrong results. So next question for Zain. Now you're given these numbers, and the question is, how would you round it to the nearest integer? Which means if the fractional part is more than 0.5 decimals, then they'll round off to the next integer. But if it is lower than 0.5, then it's going to be the lower bound of integer. As an example, 234.45 will give 234, whereas a 99.5 will give 100. What would be your approach?
Well, there's like a function you could use, right? Like a round to int or something.
Technically you can, but as we have not reached there yet, based on whatever we have learned so far, can you do it without using the function?
Well, I mean, like, I wouldn't really know how to do it like with what we learned so far, but I could just do it with like if statements or something.
Do you want to take a guess? Any other ideas that can help you here?
Could you do it so that instead this time you could have it the variables as doubles, but then how we did the typecast where we set the answer as double, we could have that as int instead.
That's a good insight in the problem. So the reason why that's a good insight is because we all know what integer does is it drops a fraction part, right? But I think you can expand more on your idea there. Is because if you convert 99.5 into an integer, it'll become 99. Or if you uh, cast 7.9 into an integer, it'll make it 7 because it'll drop the fraction as is. It won't make it 8. So how to achieve this result here? So we have partial solution here, which is we have to typecast into
So
integer.
what if we, like, if it's greater than 0.5, we just change to int, but we just add 1. And then if it's less, then just int. Whatever.
Yeah. So yeah, you're right. That can be done, but there we'll have to use if and else. We haven't reached there yet. So can we do better without using any of that? Let's quickly look it up. Right? So it's online. Let int, and then we typecast into integer. And our number is, let's say, 234.5. Right? This should give us 234, let's say 45, right? That's the first number. And then let's write down all the numbers that we had in the example. This was 33.2, 0. This was 99.50. And the last is 7.9, 7.9. So let's run this real quick. What happens? I should have put some space. That's the problem with copy pasting is you have one mistake and it just replicates everywhere. But you can see that at least it gives us partial result, which means in this case it's a right result. It gives 234. In this case is also it's right. It gives 33. But it's wrong here. It should have been 100, and it's wrong here. It should have been 8. So what can we do? What we can do is we can just add 0.5 to it all around. So what happens when we do that? Run that. Voila. This is what we wanted, right? So what is happening is we know that integer is going to drop everything after the fraction, which means if we add 0.5 to it, if the fractional part is more than equal to 0.5, adding 0.5 will make it become the next integer, right? So let's say 99.5 plus 0.5 will make it 100.0. Whereas 7.9 plus 0.5 will make it 8.4. So now we can safely drop the fractional part and we get the integer rounded off. So it's a nice little trick. We didn't have to use any math library and neither if-elses, just based on simple things that we have done so far.
Great, but what if it's already like 8.0?
8.0, let's look at that. Okay, let me change this. 8.0, right? So guess it. So it'll make it. So what should 8.0 result in? 8, right?
Yeah.
Let's run it. So you add 0.5 to it. It'll make it 8.5, and as it is an integer typecasted, it'll drop the.
Oh, okay, I get it. Okay, because it's integer. Okay, yeah, I get it.
So there it is. So maybe the math library internally is doing something so simple. How cool is that, right? These simple things we all know, but can have so this is a subtle solution here. How about the next question? Let's look at Sam. Do you want to take a stab at it? Find a square of 739. How would you do that?
This is kind of a hard one. I don't know if I'm gonna be able to get this.
This is the easiest one. You won a lottery ticket today to get the easiest question come to you.
So you could
You could just multiply 739 by itself.
You would? To
You
find
can
the
multi- You can multiply 739 by itself.
Can you do a equals 739, and then you can do a times a?
No, that would get 739 squared. We want the square root.
Yeah.
We want the square.
Wait, you want square root or just square?
Wait.
Oh, I thought it was
Wait,
the
yeah,
square
do you want
root
to
of
square it? I thought it
739.
was square root.
Oh, it's just
Yeah.
square. Okay.
Oh, well then yeah, that's a lot easier.
Either I might have said it to root, or maybe you guys thought it cannot be that easy. Must be root.
Yeah.
That'd be
But-
hard.
Square root would have been hard, right? We can't do that with what we know so far. So, but the idea here was to have something like such, and then a equal to a.
Could you find the square root of it using what we know?
Well, I don't think. Oh, never mind.
No. Square root finding. It's we can, but I have forgotten the way to do it in linear algebra. It's a repeated division that we do. So you can theoretically do it from what we have learned so far. The only thing is I've forgotten the steps to do that. And then there are like a lot of mathematical techniques that can also be used to get more efficient results. So it's better to use a library in that case, or a function rather than doing it yourself. But it's a good exercise. If you can find out manually of finding square root, you can program it. Well, so in this case, it was square is a, that's it. Fine. There it is. That's a result. Okay, let's resume. Next question, Nate. So, result of adding 1 to max value of integer. What would the result be? So the hint here is you can find the maximum value an integer can hold by calling something like that. Integer
Calling
dot
it
value.
integer max.
Yeah. So that will assign the maximum value to your int max variable. So you don't have to sign
Well, so what am I trying to find?
You are trying to find what will happen if you add 1 to the maximum value of integer.
Would it round it?
Are you answering the question or are you asking me back?
Oh, yeah. I mean,
you know what? Let me give you a company here, right? So let me pass this similar question to Parashar. Yeah, now there are 2 minds working on this. So what will happen if you subtract 1 from the minimum value of an integer?
Would it just give you an error? I mean, because
So-
isn't there a certain range that integers can actually be typed from?
Yes. I think if you all remember, we kind of briefly touched upon it some time ago, what happens when we go beyond the range. And we all thought it'll round off. So this is actually just a test of it. It will not give an error. That's there. And for what Nate was saying, it'll round off, but round off to what? Any guesses on that?
Doesn't it just like loop back around?
Loop back around to what? What
Like-
was the result?
Let's say like you added 1 to the max value. It would just go to the very minimum value.
Okay. So you're saying if you add 1 to max, then it'll become min?
Yeah, so it's kind of like an infinite loop. Like you can kind of, if you add 1 to the max or you subtract 1 from the minimum, it just goes to the other side completely.
So why will it not become 0?
I don't know. I'm just assuming that that's what it does.
It's a good guess. It's a good guess. That's the right guess actually. But there's a reason for why that happens and why it doesn't become 0. Is if you guys want to try it yourself, you can literally write it. I can wait for like maybe a minute. Give it a try. It's very interesting, yeah, and it'll surprise you.
Yeah, I did it. It gave me the positive value.
So if you print I, the max value, it is positive. If you add 1 to it, it is negative value. And then when you do a min value, print it, it's a negative value, and you subtract 1 from the min value, it becomes the max value. In fact, you'll see that you can toggle between max and min by adding subtracting 1. Then the question remains is why did it not go 1? Like when you subtract 1 from min, why did it not become 0? Or when you add 1 to max, why did it not become 0? The reason is because integer range, if you look at it, it's a 32-bit number. It's a 32-bit number essentially. So when you add 1 to it, now in those 32 bits, the last bit is reserved for sign, which means whether the number is positive or a negative, right? So essentially only 31 bits are used for storing the number. The 32nd bit is used to store the sign. So if a number is negative, its 32nd bit will always be 1. When a number is positive, its last bit will always be 0. So what happens is when you get the max value and when you add 1 to it, the carry that gets generated because of that goes and updates the 32nd bit in the integer. And when Java looks at it, it says, oh, the last bit is 1, it must be a negative number. That's why it prints out a negative rather than a 0. Make sense? Any questions on this? Moving to the next fun question. How did I break? So this is for Harris. Evaluate the following. What are the values of x, y, and z after this code executes?
Is Harris here?
Harris is gone.
I didn't see him.
Oh, he's gone?
He left a long time ago.
Okay, maybe.
He is
left
on
at
the
7:30.
he's on the Ramadan fasting.
He said he had to leave at 7:30. So
Yeah.
Oh, yeah. All right, so the question gets passed on to Sam.
Okay. The values of x, y, and z after the code execute. So x equals 4, or yeah. No, x equals 7 maybe because you add them. I don't know. No, I think x equals 4. Yeah.
So in the AP exam, you'll get something similar. So x equals 4. What about y and z?
All right. So for y, y equals 2.5, and then z equals. Wait, where is that one? I think it's b.
It's D. Okay. Anyone else has a different choice here?
B or E, but
I
I
would
think
say
it's
D.
I thought it was A.
Everyone has two answers.
One at a time.
D or D? I think it's B though, because it's after, so you wouldn't add it. Oh wait,
No,
I think
no,
it's D.
you would. Yeah, you would.
It
Yeah, it's
would
D.
add it,
It's
so
D.
it's D.
Yeah, it's D.
Because it's not
Because
printing.
it's after the code executes.
Yeah.
Okay. So far we have A as a candidate, D is one candidate, B is another candidate. Anyone else has any other choice? If you all choose one, then one of you are going to be right.
I thought that it couldn't have been C, D, or E, because it says Z++ at the bottom, and because it's the postfix again, Z has to be 2.
No, don't look at this as that problem.
Oh, okay.
Yeah.
It's after the code executes, so it doesn't matter if it's code fixed or not.
Yeah, exactly.
Mm-hmm.
So surprisingly, well, any more guesses? No more guesses? You all are wrong in this case.
Why wouldn't Z be 3 though?
What?
Why wouldn't Z be 3?
Z can be 3, yeah. So, well, the answer in this case is actually E. So why is answer E?
Oh, because it's int.
I know why. Yeah, it's int.
Exactly, there you go. So your Y cannot be a fraction. So A and B are out of question. A, B, and D are out of question because Y is a fraction there, right? But Y is an integer, so it cannot be fraction. So the only options left are C and D. Oh, sorry, C and E. And X is 4, so E is the answer. So you can actually solve such questions by elimination process as well. But if you closely look at the program here, you would naturally come to E. I think there was some confusion around Z++ being printed. Yeah. All right. Moving on to next quiz time. True or false? Simple, right? Java rounds up automatically when you do integer division. So, Edward, is it true or false?
What does it mean by rounds up?
Rounds up is to do rounding. Well, it doesn't mean to the next.
It's probably
number.
false.
It just says it is just rounding it to something.
Okay. I think it's false.
You're right. Java does not round up automatically. So next question is for let me pick a lucky draw. Gavin, true or false? Casting always results in double type.
I don't know. Hang on. Let me think about it.
It is saying if you cast a variable, it'll always be double.
I don't think so, right? Why would it double if you just automatically cast it?
Right? Casting results in the type that you want to cast. It is not always double. If you want to cast it to integer, it will become integer. If you want to do it double, it will make it double. So you're right. Let's some final questions, but let's not write a program. Let's just intuitively talk about it. If you earn $500 a day and you pay 30% in taxes, how much money will you have after 5 years? So what would be an approach in this? It's an open question. Feel free to jump in and think loud here. What it's saying is if you earn $500 every day and pay taxes means.
Do you
I have an idea.
pay the 30% taxes on the 500 or your total balance?
No, every year you pay it.
Oh, okay.
Yeah,
On your total balance. Okay.
Yeah, I would do 500 times 365, and then in parentheses, and then that times 70 over 100 times 5.
Yeah, same.
Or wait, the 30% happens every year, right?
So it says 30% in tax, which means no matter you do it every day or every year or at the end of it, all of them will have
Oh
the
yeah.
same result. But the key point here was to use the right data type. What data type will you use when solving something like this?
Probably a
Double.
double.
Yeah,
Double
I
or
would use a double.
Awesome. So I think the point here in these AP questions is not to test the math knowledge. It is to kind of test what data types you use, right? So if the question looks challenging and tough, don't get carried away with it. It's because the idea is not to test the math, it is just to test the right data type. Next question, open to everyone. If your bank account has $7,000 in it, and the bank gives a simple interest of 7.5% per year, how much money will you have in your account after 10 years? And the hint here is if A is a final amount, P is initial amount, R is rate of interest, and T is time of year, then the amount of money you will have at the end is equal to, final amount is equal to principal into 1 plus rate into time, right? So what data types will you use essentially is a question here.
Doubles again.
Double again.
yeah.
Perfect. Double again. In fact, in this case, we use double for everything, even the bank account balances, because if we make that integer, because it starts from 7,000, which is an integer, then at the end, the result, the final result, A, will be fraction, and we'll be throwing away those cents. Moving to the next one. Calculate cost of trip that is 500 miles long when the gas price is $2.20 and miles per gallon is 27. So
Doubles again, right?
double again, simple math problem. You have the distance. You know how much miles per gallon you get. From there, you can find how many gallons of gas you'll need to go to make the trip, and that multiplied by the gas price will give you the total trip cost. Moving to the next one, calculate number of chicken wings that you can buy if you have $9.43, and each wing costs 60 cents. What data type will you use for the final result? Integer. Why integer?
Because you can't buy like a decimal of chicken wings.
There you go. So now we are building the intuition here. Is we'll use integer when we know the result is going to be a whole number, but when it is fractions, no doubt it's double. The next one is the original cost of a jeans is $78. During clearance, there's a 70% off, and you also have an additional 20% coupon. What will be final price of the jeans? Well, it looks like a math
You would
problem. But yeah, go ahead. What steps will you have?
First you would do 78 times 30. I mean 30 over 100, and then you would do that, and then you would divide that by 80 times, multiply that by 80 over 100.
Okay. That's probably right. So there's that one way of doing it. The point here, of course, is to use double data type because it may result a fraction number. You can simplify this by multiplying 78, into 0.3 into 0.8. But your approach is right. You get the same result. All right, quick review. So we'll review what we have done so far. Type whitening, integer to double is automatic, doesn't work for Boolean. So you can't convert a Boolean into integer and double automatically. Java will throw a problem, compiling error. Type narrowing is not automatic, which means you can conversion from integer to double is automatic. You don't have to worry about it. But conversion from a double to integer won't be allowed unless you typecast it into a double. Operators in Java are of three types. Arithmetic, which is generally the math things that we do, plus, minus, multiplication, division. Unary is sum. But in arithmetic, you need more than one operators, operands. Right? In unary, you need only one operand, plus plus or minus minus, which is increment and decrement. A negative before the number would mean a negative number. And finally, assignment is equal to, plus equal to, minus equal to, and those are the shortcuts of writing small arithmetic problems in Java. What assignment operator does is it assigns the result to a variable. That's one key point to remember here. Arithmetic operators require two operands. Unary requires only one. Modulo returns a result. Modulo returns remainder, not the quotient. And then there's an order of precedence that Java follows to solve a problem. So that's that insight in that will give you a lot of idea on why a program is behaving the way it is behaving. As an example, we saw that situation wherein we had 1 plus 2 as a string, plus 1 plus 2 gave us 12, which was completely wrong result. But it was not very intuitive to find out why it is wrong unless we would know the order of precedence. So so this covers our section 1 of AP coursework. We have some time left. Either we can go over, like we can start with, we don't have enough time, let's not start with it. With more interesting things coming up in this course. So far it has been building the basics, getting an idea of it, learning, revisiting them, and building intuition is what is more important. Given a problem, how would you get an idea of how to solve it, right? Given a solution, how would you be sure that this is the right solution, or this is the right way of solving it? We looked at a few things so far, which are optimal. As an example, rounding off, just adding 0.5 is a very optimal way of rounding off a number. So, I would recommend work more on these kind of problems. Build your intuition. In AP exam, that's what they'll look for is what was your intuition behind the solution you proposed. So it may happen that the solution could be off a little, but if your intuition is right, you learn some brownie points there. So being said so, let me know if you have any questions, and we can answer it. Else we're done for the session today.
Just wanted to see how many of you are ready for a practice test, AP practice test. It is also practice test / diagnostic test.
That's a good thing to think about. The reason is because we all are here to learn. Today I learned something new, and of course you guys are learning new stuff here. So we all know that not everyone is going to be perfect, and it is not about finding who's perfect anyways. It is about learning and then finding out how much we don't know yet. So taking test is a very helpful way of finding that out.
Exactly.
Yeah.
Okay, so maybe next week, the following week, but Prakash, me, and Fernando will discuss, and then we'll come up with something for you guys. Questions? You all must be hungry. Okay. All right, gentlemen. Prakash, PK, and Fernando, can you stay and you can stop recording? We'll just do a quick chat. Now others can tune out. Thank you. Good night.
Thank you.
All right. Thank you.
Thank you. Bye.
Thank
Bye.
you.
Thank
Bye.
you.
Bye-bye.
Oh wait, I had a question real quick, actually.
Yes.
Nate,
Uh,
yeah.
thank you.
You
Oh,
guys
for-
record. You guys record all these. You said.
Yes.
Yep.
Where are the recordings?
Well, so you have to send me a dinner coupon and then an email ID, then I can send it to you.
A what coupon?
A dinner.
It was a joke. Just send him an email.
Wow. Nate.
Sorry.
Okay. All right. Type your email ID in there in the chat box, and then we'll share that with you.
Okay. Yeah, because it's just.
Good. Okay.
I think it'd be nice for me to look back over some of these a little bit.
Yes. Yeah. Thank you, Nate.
All right. All right. I'll see you guys. Thank you.
Okay.
Okay.
Bye.